So this is our presentation of Zaxby's Milestone 5. This is going to be presented by Will Bird, Caden Clinton, Lawson Dial, Cameron Duke, Morgan Lumpkin, and Sam Queen.
Zaxby's story began in the middle of Georgia in Statesboro in 1990, and it soon became one of the most favorite fast food chicken finger restaurants in the South. Zach McLeroy and Tony Townley, two childhood friends, started Zaxby's from the ground up. Soon after takeoff, Zaxby's moved their headquarters to Athens, Georgia, and began to expand. Zaxby's now has over 900 locations around the South and continues to feed customers 7 days a week. Zaxby's is known for their quality and service. However, although Zaxby's is broadly known for their quality and service, the Zaxby's in Milledgeville seems to be subpar. With the helpful insight from a manager at the Zaxby's in Milledgeville, we concluded that their poor service is mainly due to their outdated POS systems and card readers. This problem causes employees to slow down production and ultimately slows the drive-through. The drive-through has always been slow, but with new and improved IS systems, wait time would decrease exponentially.
To solve a solution for that problem, we have to first understand what Zaxby's operates under, and that is under a basic POS system, which most other fast food restaurants in the industry use. The POS system is the point of sale, and it consists of the cash registers communicate to each other when an order is placed. This is ideal for the restaurant because it allows it to be speedy and also easy to use for the team members. This outdated system and the broken card reader problem that our Zaxby's is facing was causing it to slow down production ultimately. So the drive-through, and in comparison, this drive-through has been very slow compared to our new RIS systems that would decrease time exponentially. And this could be solved under the micro POS systems. And this is the system requirements that are needed and methods used to determine the system requirements. System requirements need to be easy to implement. The system must be able to be swapped with possible current outdated systems to minimize costs and delays out of time, operate under minimal training. It has to be scalable. This system should be expandable as business grows. It has to have improved customer activity log to where the system can track customer trends and take inventory more accurately. Efficient. It has to be shown to have proven performance. The system has been successfully used by similar businesses and restaurants, and also easy for the customer to use and interact with. The interface should be quick and simple.
So jumping into our entity relationship diagram, the reason we made an entity relationship diagram is the sole purpose of just putting something down on paper to where we can recognize the problem and also try to find the solution within it. So you can see here we have a sales table, a card table, and an accounts table. And you can go through and you see that the sales table links to the card table through the card number, and then the account table links to the card table through the account ID. So you can really see a transparent flow of data from each table. So the sales table was created to keep track of each individual sale and the linkages to each customer, such as price, and payment method. The primary key of this table is sales ID, and the foreign key is card number from the card table. The card table was created to account for customers' names and their specific card numbers. This table allows for Zaxby's to record which types of cards are being used. This also goes into the accounts table. This accounts table is the link between customers and the bank. This table allows for Zaxby's to interact with banks through transactions which pull from each customer's desired accounts.
So we also made an access database for this information. Each table links with each table from the ERD. So you have at the top there the sales table, and then in the middle is the card table, and the bottom one is the accounts table. Now we also inputted 5 separate data entries as well as relationships of each table over there on the right side of the screen. And then we also formed 3 queries and 2 reports.
So this is our DFD0. It begins with our customer placing the order. The order goes to the cashier, and then the cashier has 3 things it needs to do. It will total up the order and send it back to the customer, send it to the cooks, and then go to the next page to do the card reading. So then the customer inserts their card. It pulls the data from a database to make sure it's a valid card. And if it is, it sends it off to verification. It'll pull the account balance of the card, make sure that's okay. If it is, it'll pull the payment information, print a receipt, and the customer will be on his way. If there are no funds, then the cashier will be alerted and they will tell the customer. And that'll be it for the DFD0. The human interfaces. So the POS system is color coded so that the meals are easy to differentiate from each other. Each category is under it to go to different meals and things to buy. The reset button clears all the cart, and the pay goes to the next screen. There's functions, so you can, if you have a frequent buyer, you can quickly make an order for them, cancel an order and hold an order, basic. And then the next one is top left are a bunch of discount codes and stuff to use for birthdays and employees and managers, such and such. The alternate pay method button is for people that want to use cards or like multiple cards or half cash, half card, gift card redeems, self-explanatory, and a tax exempt order if this POS system needs to be ported to a location that is tax exempt, such as Robins Air Force Base or anywhere where taxes are exempt. Back to menu button goes back to menu. Cash is to handle cash, scanners to handle gift codes, and what are they called? QR codes. Credit card is to handle credit card. And that is it.
So now we're going to talk about the implementation. The first thing that's going to happen is the physical design of the POS system is going to be coded in a coding language. And once that's done, the way that the POS system is going to be tested is by using the user acceptance testing. So each of the users will have the opportunity to test the POS system, make sure it really works, and try to find malfunctions within the system. And it's going to be a direct installation. So as soon as the new POS system is ready to be installed, the old POS system will be turned off. And then we have user training and instruction documents. So each of the employees that are going to be using the new POS system are going to be trained. And then there will also be instruction documents like a manual of how to use the POS system as well for their use. And then if an employee still does not know how to properly use the POS system, there's a help desk where somebody will be on call to assist them with any questions they may have, or if the system fails in any way. And then of course the system will have a disaster recovery and backup system so that in case of a disaster, all the information within the system will still be able to be recovered. And we believe that implementing this system for Zaxby's will drastically improve the time of the drive-through. So thank you.